In this lesson, we focus on the repair work quota for equipment maintenance. Previously, we introduced maintenance methods and repair categories. We learned how to determine the repair category when a problem occurs. That is, we decided when to repair. Next, we must determine how long the repair should take. This lesson covers the following topics. First, repair complexity factor. Second, methods for setting the repair work quota. First, repair complexity factor. To determine the normal repair workload for a certain type of equipment, we first estimate its repair complexity factor. Hence, the concept of the repair complexity factor is introduced. The repair complexity factor is a notional unit that indicates the degree of repair difficulty. It compares the overhaul labor of the equipment with that of a selected standard machine tool. This defines the relative complexity of the repair. In China's machinery manufacturing enterprises, the repair complexity factor has long been used as the basis for developing repair work quotas. We study this factor to establish the repair work quota. A detailed work quota should include the following items. First, maintenance cycle norm. Second, repair complexity factor. Third, maintenance labor norm. Fourth, downtime norm. Fifth, maintenance cost norm. Sixth, spare parts stock norm. The methods include the statistical analysis method and the technical estimation method. First, let's look at the statistical analysis method. It analyzes repair records by category and repair type for the enterprise's equipment. It excludes consumption caused by abnormal factors. Then uses an averaged advanced value to formulate average repair work quotas by category and repair type. Its advantages are clear. The process is straightforward, and it only requires compiling historical data from past repairs. The workload is relatively light. However, it demands high completeness and accuracy of the statistics, and it cannot reflect the impact of technological progress and other factors. If historical statistics are used as the standard for current work, the result may fall below the advanced level of the industry, or even below the average. Therefore, it is suitable for setting per-unit repair work quotas for standard models when the enterprise owns many units of the same type. At present, many domestic enterprises still adopt the statistical analysis method. When using this method, note the following. First, define the equipment categories for which to set the repair work quota. Determine categories based on how many units of the same type the enterprise possesses. If a large number of the same type of equipment is in use, that type should be included in the repair work quota classification. If the enterprise has only 1 or 2 units of a given type, do not include that type in the quota categories. Second, define the grading of the repair complexity factor. When the actual man-hours per unit of the repair complexity factor exceed material and cost consumption, equipment with higher repair complexity factors is considered more complex than those with lower ones, and the workload increases with the complexity factor. Therefore, similar equipment can be divided into several levels according to their repair complexity factors, which helps improve the relative accuracy of the repair work quota. Third, statistical contents. Data should be compiled based on the mechanical equipment repair man-hours statistics sheet, downtime statistics sheet, spare parts and materials statistics sheet, and equipment maintenance cost statistics sheet. Fourth, collect repair records for analysis. Gather as many repair records and related data from the past 3 years as possible. Record each item in the statistical tables. Fifth, analyze statistical data. Develop the repair work quota. First, check whether the number of equipment samples is sufficient. Second, examine whether the difference between the maximum, minimum, and average values is significant or reasonable. 3. Evaluate the reduction in repair workload caused by new technologies or processes. Fourth, compare the new repair quota with the previous one to ensure it represents improvement. Sixth, average repair work quota for categorized equipment. First, under normal conditions, The overhaul workload of equipment of the same type and model increases with service age. Therefore, the influence of service life should be considered. Second, for special or unconventional repair items, appropriate adjustments should be made based on the average repair work quota. For example, for an equipment overhaul that includes partial modification, its repair work quota may be appropriately increased. Third, try to minimize downtime for key and critical equipment. That is, aim for an optimal balance between repair cost and production loss. Fourth, the average material quota for categorized equipment is used only for preparing the annual comprehensive plan. The technical estimation method, on the other hand, is based on the predetermined repair scope, process, quality standards, and the current maintenance organization of the enterprise. It performs technical and economic analysis and estimation for the entire repair process, and develops norms for repair man-hours, downtime, and costs. These serve as economic indicators to control the repair process. It is formulated based on the actual condition of the equipment before repair, combined with previous repair experience of similar equipment, and refined through detailed analysis. Thus, compared with quotas derived from average repair work data, it is more practical and accurate for individual equipment. The technical estimation method better aligns with technological development, and is therefore the trend for future quota formulation. Let's look at an example. Here is the structure of a centrifugal pump to be fully repaired. We need to determine the total personnel, working hours, and cost for the entire repair process. The estimation mainly includes the following steps. First, disassemble the centrifugal pump. Estimate the types of workers, number of personnel, and working hours required. Second, analyze the repair procedures for each component of the pump, and estimate the worker types, personnel, and time required. Third, analyze the fitting and matching repair procedures for related components, and estimate the worker types, personnel, and working hours. Fourth, for repair tasks requiring internal or external subcontracting, estimate the outsourcing labor cost. Fifth, analyze the final assembly procedures, and estimate the worker types, personnel, and working hours. Sixth, estimate the worker types, personnel, and working hours required for testing, inspection, and acceptance. Seventh, analyze and identify the critical path of the entire repair process. Calculate the minimum downtime for the equipment repair. Eighth, based on past experience with similar equipment, estimate possible additional costs for spare parts, materials, and labor during repair. The resulting downtime and downtime norm of the equipment are obtained by compiling and summing the man-hour norms of all tasks. Then, calculate the total maintenance cost and cost norm. During equipment disassembly and inspection, some unforeseen defects may be discovered, which could affect the overall repair schedule and increase workload. Therefore, when determining downtime, an additional 10 to 15% should be added to the total duration of the critical path. When calculating total man-hour norms, an additional 15–20% should be added to the measured values. The method for calculating costs is similar, so we will not go into detail here. That concludes today's lesson. Thank you all.